Good afternoon, everyone. Welcome to ROI Tech Talk. Today we'll be talking about Powervent water heaters, troubleshooting. Today's agenda will include some of the installation venting processes. Most service calls in the field tend to be a venting issue. Sequence of operation is the most important part of repairing any appliance. If you know the sequence of operation, then you can troubleshoot everything. We will cover how to test components within a Powervent water heater, cover the most common error codes in the field. At the end of the presentation, we will have time for questions, and please use the chat feature to ask questions during, and we will answer them in the question and answer section. So what is a Powervent water heater? A Powervent water heater uses a fan or blower to assist in the removal of exhaust gases from a hot water heater. If the water heater is installed in a location that doesn't have access to a vertical vent or chimney, a Powervent heater may be your only option. Powervent water heater requires 50 cubic feet per 1,000 BTUs of combustion air. Very important part. Uses PVC, CPVC, or polypropylene venting pipe. The vent needs to be sloped away from the unit at 1/4 inch per foot. Has a rotatable blower. So this 3-position rotatable blower comes in handy when you have a restricted head height. It's also important to know, coming off of that, you need 6 inches of pipe before your first turn. So if you look here, right off of here, you need 6 inches of pipe before you put an elbow on. So combustion air. This is a big problem with installs today. Many times the basement has been refinished and they close that unit into a closet. Remember, it takes 3 things for combustion to happen: oxygen, a fuel source, and ignition or a spark. So let's look at a typical 40 to 50 gallon unit. When an 8-foot ceiling, you would need a room size at 14 by 20. How many mechanical rooms are that big nowadays? And keep in mind, you have to delete out the space that the furnace or boxes or a laundry, wash machine and dryer would consume. And also I need to look into, is there other gas appliances such as a furnace using the same combustion air that must be accounted for as well. So if you had a 90+ furnace that was in that same room, that 45 and that 90 would give you 135 BTUs that you need for combustion air, and you need a room size at 28 by 30. So if we don't have that correct makeup air or combustion air, we need to bring it in through a permanent opening from outdoors or another room. And we accomplish this by installing high and low grills into the wall. Each opening shall have a 1 inch, have a minimum free space of 1 square inch per 1,000 BTUs of total input for the gas heater, but not less than 100 square inches, meaning a 10 by 10 is the smallest you can use. In the venting, so when we need to upsize the venting to accommodate the equivalent feet that we're running, an adapter or bell coupling needs to be installed as close to the blower. So here we have we're upsizing from 3 inch to 4 inch. In doing so, we need to supply a 3x4 adapter here, or bell coupling is what I call it. And if you look here, a 3-inch vent pipe, 3-inch max length, meaning we need to have that pipe as close to that blower as possible. Meaning you can't run your 6 inches, put a 3-inch 90, and then upsize. That's not correct. Acceptable fittings, no street 90s. And the reason for no street 90s is we want 6 inches minimum between elbows. Preferred practices: Well, I don't understand why you would do 390s to turn versus using 245s to accomplish the same thing. In this chart, I'd like you all to take notice that your fittings and elbows do account for equivalent feet inside of the venting run. So a short pattern 90 would be equivalent to 8 feet. A long radius one would be 5 feet, and your 45 would be 4. I also want you to look at section A right here. 6 inches minimum. Obviously, we want to add our strappings and support so we don't have sags and bellies inside the venting pipe. In here, this applied 45 that comes with the unit, the reason why we want a 45 and not a 90 here is because we don't want combustion gases and hot air to be trapped inside this venting pipe, causing it to melt or the heater to overheat as well. So with a 45 on the end of it, we're allowed to exit our exhaust freely without the fan blowing as well. We don't trap it. That's also where the restrictor plates go. So our restrictor screens inside these venting terminals is located in the bag with the heater. It's important to install the correct restrictor. Too much back pressure can cause the pressure switch on the blower to fail, or the flame to be pulled off the burner and the flame sensor to deactivate. Sequence of operation. The most important part of troubleshooting is knowing what steps the unit takes to produce hot water. When you know the sequence of operation, you will not even look at that error code being displayed on that gas valve. I don't ever look at it when I service anything. I cycle that heater and go from there. So within that sequence of operation, thermostat will call for heat. The thermostat is located in the gas valve. The heater controls the check to ensure the blower pressure switch is open. So it has to prove the switch is open before the blower kicks on and then closes it. Then the blower is energized. Gas valve checks to ensure the pressure switch closes, indicates the blower is in operation, and there are no venting blockages. The igniter is then engaged and the main gas valve is opened. Main burner comes on and the flame is sensed by the controller. Main burner continues to run until the heater reaches temperature, goes into its post-purge, and then remains in standby until another call for heat. So we look at it on a component aspect. We go from 1 being power to unit, 2 checks for the correct ohms through the flame sensor, through the flammable vapor sensor, I'm sorry. Then it will check the high limit string is open, blower turns on, ensures pressure switch closes at that point, the hot surface igniter is energized and the gas valve opens. The flame sensor detects flame and unit runs until thermostat is satisfied. This is a very important procedure to know in order to troubleshoot. The electrical schematic, it's a sticker that's on the heater, and it's very handy to know what wires do what. So when you need to go to test in a pressure switch, knowing it's one of the wires is coming off the black, coming off the high limit switch, and the other one would be the yellow. Your power going up to your blower would be number 2 and 5 coming off of that, which are black and white. Your ground obviously being green. It's a very handy tool in the aspects of troubleshooting. Components. Now that we know the sequence of operation, let's look how to test components. Flammable vapor sensor. Safety device that it will shut the unit down if flammable vapors are present in the room. Normally operates in a range between 1,000 and 100,000 ohms. To test this, we unplug the terminals, set your multimeter to ohms, and if outside the operational range, you will need to replace it. If the switch is outside that range, it may recover if you take it outside for a period of time. But when the sensor is out of range, it does cause a hard lockout, and that'll need to be manually resetted. There's a short video on resetting the gas valve. You need to pass hot twice after that. Your high limit switch. Normally in a closed position, so the 12 volts carries through it like it wasn't even there. Trips at temperatures above 145 degrees. To test, remove both leads and conduct a continuity test. If open or failing, you need to investigate the venting or the intake air. Quick diagram to show you what the setting is for continuity. And here's a video on how to test this. That's where it's located on the blower. Unplug the one spade connector going down to the control wires, and the other one is located on the pressure switch. Turn your meter to continuity. And then it should ring out from there, or beep. Troubleshooting pressure switches. Must prove open before blower will start, meaning that you cannot bypass this switch. The gas control has to see that it's open before it's closed. Normally opens position without vacuum. The vacuum closes the switch and 12-volt signal is sent back to the gas valve. To test switch with multimeter set to continuity, remove both spade connectors from the switch and turn blower on. Does blower close the switch? So looking at this diagram, so the sensing port is where our vacuum from our blower is coming and plugging into it. And on a normal state, our diaphragm is flat, pulling that switch contact away. So that means we're in an open position. So when that blower receives power and comes on, the vacuum then is created, pulling that diaphragm up and making those contact switches go active. Make sure which switch you have before testing. In this chart, you can see there are 3 typical switches that we use: a negative 0.27, a negative 0.37, and a negative 0.99. The input value is the BTU input value is usually what indicates which switch we use. So usually on our 42 and below will be the negative 0.27. Our 50,000 BTUs was usually a negative 0.37. And when we get up to our 72,000, 62,000, we're at a 0.99. Pressure switch testing. I like to test to make sure that it is open before. So I'll cut the gas valve off. Remove my spade connectors from my pressure switch. Make sure I'm set to ohms. or continuity, I'm sorry. Now we'll test to make sure that it closes. Blower turns on. And we should ring out. So our blower vacuum test. Double check to ensure the vacuum hoses are not cut or cracked. Run into this a lot with heaters not coming on. It's usually on new installs where they're carrying them down and they don't realize that they crack or rip or tear that hose. And lately I've had quite a few that are coming back with breaking that brass fitting off the top of this blower. So you know that brass connection is not replaceable as a part, so the entire blower has to be changed. So remove vacuum hose from the pressure switch and zero your manometer to inches water column. Turn on blower, and do you have a reading of inches water column, a negative inches water column to engage the switch? If not, you more than likely have a venting issue, and you refer to your manual for proper venting procedures for that particular unit. So blower vacuum test. That is a manometer. Make sure my setting is in inches water column. I zero it out. We remove the vacuum hose. Turn my blower on or gas valve on. And you see we have a reading of negative 0.88. And on that particular unit, it's a negative 0.27 to engage it. The igniter. Igniter reaches temperatures of 2,000 degrees. It takes about 15 to 17 seconds for it to warm up. It's made from a silicon nitrate material. 120 volts is delivered from the gas valve to the igniter to ignite the gas. Troubleshooting it wise, you need to ensure that you have no burnt or broken wires leading to it. And you can always test the gas valve to see if 120 volts is present in the sequence of operation when it would call for that to, which would be right after the proofer switch closes. Good part to know is the ceramic over time will become cracked or damaged, which then can cause your igniter to fail. Flame sensor. All the flame sensor does is check to ensure the flame did light. Must proof signal in 4 seconds or the gas valve will reset itself. Check to see if the wire is burnt or broken. And there's a spade connection on the outside of the unit leading up to the gas valve for replacement. And a lot of times that right there at that spade connection is a failure point from somebody accidentally kicking the wire, carrying it the wrong way. To clean this flame sensor, clean with a fine steel wool or a $1 bill. Or if you got plenty of bank, you can use $100 bills. Common error codes. There's 16 different error codes in total. We're going to cover 3 error codes that covers about 80% of the codes found out in the field. So a 6.1 flash code, failure to ignite. First, check to see if you have flame. If you did not get flame, first thing to check would be your incoming gas pressure to make somebody didn't shut off a valve. Is it an LP install that their tank has gone empty? Because that 20% of a propane tank is considered empty. If it did light, you need to look at your flame sensor. If the burner kicked on for a couple seconds and then kicked off, more than likely it's your flame sensor. Again, we would check our wiring on that and clean it. If neither of those are the cases, more than likely you have a damaged or faulty gas valve. A 3-flash code. Pressure switch failed in operation. So it never closed or failed in operation. 1, check that sensing tube, that vacuum hose. That's usually where this code comes out. It's usually on a new install, 3-flash code, it's tore. So check your blower vacuum. From there, you'll know whether or not you need to check your venting. If you could have a blockage in it, you could have non-supported pipe, venting pipe that has now caused a sag. A small blockage could set that high limit switch off as well. So we could be overheating and shutting down in that aspect, because that high limit switch is in the same string that the pressure switch is. So do we have a venting issue? 9 times out of 10, if it's not that sensing tube, there's a venting issue. 6 3-flash code. Flame lost. Somewhere in the heating cycle, we lost flame. Again, we're going to check our flame sensor. So we're going to cycle our heater again and see where the trouble starts. So that falls back into that sequence of operation. If you know sequence of operation, you can troubleshoot and figure out what step you lost. If the flame is pulling away from the burner. So we could have where you don't have the restrictor installed at the end of the pipe, and the volume of air we're moving through that unit is too much. And when that happens, we start to pull that flame away from that burner, which then could pull it away from the flame sensor, shutting down the unit. Check your flammable vapor switch. Was there a paint can that fell off into the room, or somebody spilled something? Are they refinishing floors? Is there a gas leak within the house? So there we have to go check the flammable vapor switch again. And remember, that causes a hard lockout, which then will means the gas valve will have to be reset.